Hi there, this is Emmy and Courtney, and this is our homework 16 for Engineering 460 digital simulation. So for this problem, it's asking us to show a GG1Q simulation in MATLAB. And so the aim of it is just to estimate the long run average line length, where the line length is the number of customers in the queuing system. It includes any customer currently being served. The queue length is the number of customers waiting for service, and basically it has these three-phase methods right here, where we have the bound state changes are the customer arrival and the customer departure. And the only condition state change is the start customer service. And so to kind of best explain this, I found this visual model online, which is a pretty good depiction of like kind of how this works and how Little's law works. And so it shows how a single queue server system works, and it includes the inner arrival time and the service time. The G stands for the general distribution with a known mean and a known variance. Basically, GG1 means that the system's inter-arrival and service times are governed by a general distribution, and that the server only has, or the system only has one server. And so first, in this model, what we have is we have this entity generator, which creates our simulated customers. And then we have our function here that represents the inter-arrival times for our customers. And we can adjust that just changing this knob here if we want. And then we have this entity queue that stores all of our customers that are to be served in the first in, first out order. And then lastly, we have our entity server that depicts our server, and it serves our customers based on the service time. So if we go ahead and run it, so I paused it because my computer's really slow and I let it run, but we get our display blocks over here, which shows the queue workload, the queue waiting time, the average server time, and the average server utilization. We also get this scope window over here, which lets us compare our empirical and theoretical ratios according to Little's law. And Little's law simply states that there is a linear relationship between average queue length and average waiting time in the queue. The relationship is that the average queue length equals the mean arrival rate divided by the average waiting time in the queue. So this is all for visual sake. They use the uniform arrival time, but for my actual code, it's down here, and I use a Poisson distribution where I have an arrival and a departure time, and then I'm seeing if that the sum of my departure times is greater than my sum of arrival times, and then I'm just kind of calculating that queue length. So I'll go ahead and run this here. And then we get the queue length of 42, mean of 15, mean waiting. And so this is the Little's law. This is just the general one, as you can see here. It's just the mean wait time, and this is by Little's law. We can also have another visual representation. We can plot our wait time and see what that looks like here. And obviously, since we're generating random numbers, we're going to get a little bit difference. But this is how you can see just the whole QQ1 server, or the whole system in general. But yeah, that's our homework 16. Thank you so much for watching.